I'm the lead of the cloud product here at Dgraph, and with me today I have Tiaga. Tiaga, would you like to say hi to our guest?
Hey everyone.
Yeah. So Tiaga is the tech lead for the UI team here at Dgraph, and with us we have Naman also.
Hi guys.
Perfect. Yeah, so we are back after some time, and we have some exciting news around product and features that we're gonna release in the coming days. And so let's start. So yeah, so this is the agenda for today. So first 10 minutes, I'm gonna talk about some product updates that we have for you guys today. And then we have some exciting demos by Tiaga and Naman, where we'll be talking about Dgraph Lambdas and some new capabilities which we have for our Dgraph administrators, DB administrator over the cloud. And the last 10 minutes for a few of the questions that you guys might have. In the meantime, it's not always possible for us to answer all the questions in this call. So you can go on this link, bit.ly/dgraph-call-9, and you can post your questions there, and we'll make sure that our team will respond to all the questions that you guys have over the discuss post. Perfect. So the first product updates which we have today is the new release we're gonna have, which is 2109. And this release is actually a months of effort that the whole team has put in. And one of the major functionalities which we have in this release is the serialized roaring bitmaps. So bitmaps, roaring bitmaps are around in the industry for quite some time, and they are extensively being used in multiple search engines. And we also saw the opportunity that we can integrate that into Dgraph, and can extract some great performance improvement over what we currently have. And then we started to implement the roaring bitmaps, but when we did integrate, we found that the serialization which the original packaging has, the roaring bitmaps, it's not quite performant enough for our use cases. And then we set on to build the serialized roaring bitmap, and what we found was that the approach, right, which we designed was 4 times faster. It uses less memory, 4 times less memory, and does 25 times fewer allocations. So it has same concepts which roaring bitmap has, but what it does is, the major difference is that it has the same data format which is required for disk as well as for the network transfer, which is the bytes. So there is no need for extra JSON marshal and unmarshal between the network transfer and communicating data across the layers. And that's how we were able to actually extract great performances out of it. So this is like a few examples which we had. So for a data set, right, this dimension data set which is identified by the roaring bitmaps, what we saw was that for the CPU utilization, the roaring bitmaps, the original package, is taking much more time, like in the ratio of 4 to 5 times more, what is we are able to get it from the serialized roaring bitmaps. And same goes for memory utilizations and memory allocations. So that's how we find that, okay, with the serialized roaring bitmaps, we can extract some great performances. And we have this in our public offering. So you can check out github.com/dgraphio sroad. So do check it out and play with it, and do share your thoughts over the discuss community. But what this actually did to Dgraph and the query performance is this. So we tested it on one of our own backend, testing backend, and we have set of around 2,188 queries, and the data set has around 2.7 billion edges, as well as 670 million nodes. When we ran this, in comparison to our previous version, which is 2103, we found that For the 67% of the queries, we actually gained around 10x performance. Whereas for 10% of queries, the performance gain was around 5x. For 7%, it is 3x performance improvement, and 2x performance improvement for 11x. Oh, sorry, 11%. And the comparable performance compared to what we have in 2103 for only just the 5% of the queries. So we realized that with integration of serialized roaring bitmaps, we actually made our queries 67% of our complex queries much more faster, much more performant, and with less memory and less CPU utilization. So that was the major goal which the whole team was working towards, and kind of we have achieved this in around a year now. It's been a year since we started working on the roaring bitmaps. The other improvements which we have for in 2109 are we introduced the concurrent mutations. And what this means for Dgraph is like all our mutations are now 2 times faster, as well as with this, we don't need ludicrous mode. So with 2109, we have actually removed ludicrous mode because now we have a more performant solution with transactions and concurrent mutations. Now, besides from this, we also implemented faster online restore, and we did introduce the incremental restore in this release. What this means is we actually implemented the whole online restore using the map reduce algorithms, and it made our restore processes 4 times faster. What this means to our community and to our customers is that there is less downtime in case of upgrades or cluster recovery, right? And that's the third thing which major thing which we introduced is the posting list cache. So now the posting list, which is the integral data unit of Dgraph, we introduced caching there, and what it means is less disk reads while querying the data, and it actually improves our query performance by a great margin. Besides from that, we have one major feature change in Dgraph, where we now have fully integrated lambdas along with the Dgraph itself. Now we don't need to set up some other servers to run lambdas. Lambdas are now the integral part of Dgraph. Naman later on in this call is going to talk about the changes which we have made and how it impacts the life cycle of lambda with Dgraph. There are other more features which we introduced, like hot tablet move, which is a efficient way to move the data once the alpha joins the group. So now writes won't be blocked for longer duration, right? In case of sharded cluster and there is a data movement across shards. Similarly, we also provided, we also added an efficient snapshot transfer. And what this means is, so if a new alpha is joining the cluster because of upgrade or because of any cluster recovery process, it will take less time and there will be no more lags, major lags in, for your cluster to become healthy. So there are multiple, performance improvements that we have made in this release. And yeah. And these all these changes will be available soon to the public. We'll soon be releasing the public release, and we are currently testing few things, and we believe we are in good state, and soon we'll be releasing the public release. Yeah, so on the cloud side, in the past couple of months, we have actually the fully functional console over the cloud with complete multi-tenancy and ACL support. At the same time, we have also added multiple machine configurations. Like if you go to cloud, you can see that we have now 4C, 8C, 16, 64, 48C, all different configurations with different memory options so that you can run your production workload in a more efficient manner. All the new dedicated backends right now are running on 2103. And I'm happy to announce that from today onwards, we can upgrade to version 21.09 on demand, and you can, test the new changes out, which I just discussed before. Also on the cloud front, we have the Prometheus integration available to all the dedicated backends so that you can actually integrate monitoring and alerting on your end. And, you can be aware of what's happening on your cluster at the Dgraph side. And another major thing which we introduced in cloud is the sharding. And now all the dedicated backends will have the option to shard their cluster and actually scale with their data. So these are the multiple things which we updated in the cloud in recent months, and we are actually getting seeing some good traction from the users to actually they are happy with these features and they are quite extensively using these things. So upcoming changes. So the major priority for Dgraph in the coming months is first the GA release of 21.09 so that all our customers will be utilizing the features that we have did in the past couple of months. So all the query performances and everything, we want that to reach to you guys as soon as possible. So that's the first priority we have. The second thing is most of our customers are asking for whitelisting the APIs for their dedicated backend so that their backends are not publicly open, their URLs. So that's another set of features on which the team is working on, and it will soon be available to all the dedicated backends over the cloud. The third thing which we are working on right now is to have more improvised key-based anonymous access. What we currently have in terms of access is the structure is quite rigid, that you can only have admin and DQL based identification over the access keys. What we want to have our customer is more easy way to manage the access over the backend. And when I say easy way to access the manage, what I mean is, so we might have the use cases where we only want to give access to some particular namespace or some particular types only. So all these use cases we're going to cover in this key-based anonymous access, and it will soon be available to all the customers on cloud. And the third and the fourth thing is the complete support for read replicas and CDC over the cloud. So it's been it's been pending for some time, but we have prioritized it, and it's going to be soon available to the cloud infrastructure. Perfect. So yeah, so these are all the updates that we have for you guys with respect to what's happening with Dgraph and what you can expect in the coming months. Now I'm going to hand it over to Naman so that he can actually talk about the changes which we have made in Dgraph Lambda. And yeah, over to you, Naman. I'm stop sharing my screen.
Thanks, Aman. The updates look really exciting to me. So, all right. So now we'll start and see so today in this demo, we'll talk about Dgraph Lambda and how it can help a developer build complex logic into their backend itself with a rich business logic. So Lambda basically provides a way to write our custom logic in GraphQL API itself in JavaScript. And that really extends the functionality that you can achieve through Dgraph. In simple terms, it eases the job of developers as they can embed their complex business logic within the backend and without having to spin up external servers. We'll also see with the new redesign, as we closely integrated the Lambdas with the database, there's no need for external management, and we see a good performance gain as well. So Lambdas in general can be used for a variety of use cases. Like you might want to perform some data derivations, like some of the fields might be computed, and you might want to do some data sanitization, like removing some of the parts of the user input data or processing it before adding them to DB. So that you can do through Lambda. Also, there might be use cases where you expect user to give minimal input, and the DB can then fetch the data from some other external third-party servers using REST APIs, and then basically embed that data into the DB. Like you might want to uh, ask user for adding a movie by just giving a title, and then you can fetch the rating from another server. And another use case might be like this, like you want to notify users of an event. Say you create a user and you want to send him a welcome email. With Lambdas, you can send emails to them via the Lambdas. And there are other use cases like you can trigger the jobs and other custom data pipelines. So let's get started. And first of all, see like what are the changes that we made to Dgraph that closely integrates it. So what is new? So earlier what we used to do is like user has to set up their Lambda servers externally, and Dgraph Lambda, Dgraph Alpha talks to it. And that basically produces lots of hassle for a developer. I mean, they have to manage their own Lambda servers externally as well. With new changes, the Dgraph Alpha launches the Lambda servers itself based on the commands. Like you can specify you want to launch 4 Lambda workers and with other parameters as well. So that becomes really easy, and that leads to better performance as well. And what I mean by closely integration, like earlier the Lambda scripts were stored outside of Dgraph. With this new change, the Lambda scripts would be stored within the Dgraph, and you can use the APIs like admin APIs called update Lambda script and get Lambda script to do that change. So quickly, let's see like what are these changes. So I'll just show like if I run Dgraph alpha help, over here I see a new flag Lambda. It was earlier not there. So with flag num equal to 1 or 4, you basically specify like how much how many workers you want to launch for the Lambda processing. And there are other things as well, like ports and uh, uh, how much time after which you want to restart the servers if they are unresponsive. So this is basically handled by the alpha itself. You just add this command and the alpha would, the Dgraph would spin up those Lambda servers. So moving forward, the cloud integrates all of this for you. So if you go over here and if you go to the GraphQL endpoint and see the admin API, in the mutation you see, oh, all right, in the mutation, you would see this new API, update Lambda script. So basically it takes an input, a base 64 encoded Lambda script, which can then be used to do processing. So first of all, I'm adding a simple Lambda script. I'll directly first add it over here and then see like what is the output. So Lambda script, I query it, and so basically I've added the script. And if I go to the Lambda tab, so over here you can see that we added this script. So first of all, adding a script is a wrong idea before adding a schema. So first of all, let's proceed with adding a simple schema. So over here, we'll add a simple schema with the type, say person, and it has type field ID, and it also has type field first name. It is of type string. We add another field last name. It is of type string, and we add another field, say full name. This is of type string, but we will also add a lambda to it. By specifying the lambda, we basically are saying that this particular field is being powered by lambda, and that would involve our custom logic that we can specify through the script. So let's deploy the schema. All right, so as you can see over here as well, like we have added the lambda fields which specifies that it is powered by lambda. So after doing this, we also need to add the script, which we have already added. In this script, you can see, basically we have written a function that would resolve our full name. In this, you can see that it receives few inputs, few parameters. One is called parent. There are others called GraphQL and DQL, which allows you to talk to Dgraph Alpha and make GraphQL or DQL mutations. So in this, you can see that the parent attribute receives all the fields of the parent type. In this case, we had field person, and we can access the first name and the last name of it. And we are just appending, doing a simple, very simple processing over it and returning the full name. Also over here, we have defined the function, but we have not yet attached it with the field. So over here, we are specifying that for the person, for the type person and the field full name, you call this function full name and resolve it. So this way is how the resolvers are being defined and attached to the fields. So we have already deployed it. So let's see it in action. So we go to the GraphQL tab and basically add a mutation for adding a person. I'll add first name Naman and last name Jen. And over the person, we'll query first name, last name, and full name as well as ID. So when we run this query, we are specifying these inputs, first name, last name as the input, and the full name would be computed through the Lambda. It is being powered by Lambda, and we just specified the resolver for it. Let's run it. Great. So this came exactly as we expected, like full name is being computed by appending the first name and last name. So now as we have become familiar with Dgraph Lambda, let's move on to some more logical, more complex examples. And for that, I'll basically modify the schema. I'll add another type called movie. And yeah, so so I have basically added a type movie, which has a title of type string. By ID, I am defining that this particular field would be unique across the movie objects. So title would be unique for movies. And the idea here is that user would input us, give us the title, and we would get the plot and the rating from an external server. So that we would do through lambdas. So for that, we have defined a mutation as well called new movie, which takes in title as the input. This is provided by the user. And then it basically does the GraphQL mutation to alpha and returns us the result. We have specified the Lambda directive as well. That basically specified that this is being powered by Lambda. All right, let's deploy it. After that, we'll add the Lambda script for it as well. So I already have the script. We can see that in the diff. So basically, additionally, we have already also added one more mutation called new movie that gets resolved through new movie. Over here, we can see that earlier it has parents, but additionally, it also has args and GraphQL. Args are the parameters that get passed through the mutation. So in the mutation new movie, we defined that we will pass title. So here it's how we can access it, args.title. And it also provides an object GraphQL that helps us talk to the alpha and do GraphQL mutations or queries. So here, what we are doing is we are basically adding a URL, and I'll switch off the diff mode. So basically we are adding a URL and computing the rating and plot from the external server, and then basically inserting it back to the DB. The title is the input field, and these are the computed field. Also, we are logging few results, few in between results, so that might help in debugging later on. So we also return the movie type. As in the schema, we defined that it returns the movie. So we are returning the movie object itself. Otherwise, it will complain that the data format is not correct. So we need to return the movie that we are getting from here. All right, we have save it. Now let's run few mutations. So I'll add one mutation, new movie. Say I add Hulk. I'll query the plot. I'll query the title. I'll query the rating. So here you can see that the title is the input and it was able to fetch it from the external server, the plot and ratings, and set it within the DB. Also, we can add few more movies like say Avengers or say Iron Man or say uh, uh, what else? Say Deadpool. So it basically inserted four movies and the sum of the data is being fetched, processed through the lambdas. Great. Now let's see, we logged few things. Let's see, were we able to get the logs? Okay, so we get the logs. So basically we get the IMDb data. It has lots of data and through it we fetch the IMDb rating and one more field. And this is the final result that we are returning. So yeah, these logs can be really helpful when the things go wrong, or we are just building the scripts in development phase. So this can be really helpful. So, I mean, yeah, uh, this looks great. So we'll proceed further and see one more example that would be a simple, quick one as well. So basically over here, we have added one more thing that one movie can recommend other movies. And we also added one movie rank. So the idea here is that we want to rank the movies based on some algorithm. So if a movie is recommended by many movies, then the score of that movie should be high. So we would be using PageRank algorithm that is implemented in JavaScript, and you can basically implement a lot of data processing that you want. Basically, you could cover any graph algorithms uh, externally, and yeah. So basically, it has type query, and movie rank is the resolver, which takes in input max iterations and returns the rank. Rank has title and score. We deploy it, and after that we'll add some more data to add some connections. So I have the mutations ready. So for the movie Hulk, we are adding few recommendations to watch Iron Man and Avengers. And say for Deadpool, we are adding recommendations to Iron Man, Avengers, and Hulk, all three. And for the movie Iron Man, we are adding few the recommendation to Avengers. So we basically see that all the movies are recommended Avengers, so it should have a high score. We'll also update our Lambda script. So we go through Lambda tab. One thing to note is that through cloud we don't need to call it via update Lambda script. Uh, that option is also available, but cloud makes us simple to use that. Basically, we just edit the script over here and we can do our processing. So in the diff mode, if you see that we basically added one more query, movie rank, and that is being processed through query rank, movie rank. And over here, we just add this movie rank function. So in this movie rank function, basically, we get the args. Through args, we would fetch the max iterations and a DQL object that would allow us to make a DQL query to the dgraph. So the format is really simple. DQL object gives us two options like query, and there is another field called mutate through which you can run a DQL mutations. So we fetch few results like count, and we fetch more data, and now we have all the data. Now we can do the processing. And here we do the processing, applying a basic, very simple PageRank algorithm, not adding much features right now. And return back the data in the same format. Like the rank expected, the title and the score. So we are putting that way and returning back the result. So we updated the script and now we can go to the query tab and basically uh, set the fields like max iterations and get back the score and title. So here we can see that Avengers was being recommended by a lot of movies. So the score of this gets high, and similarly the score is computed for other fields as well. So yeah, I mean, in today's demo, we basically saw that through lambdas, you can do a lot more. And with the new changes, as we saw, that you don't need to manage it yourself. You just basically need to specify a flag like lambda num is equal to 2. So it would spin up 2 lambda servers, which would process all your lambda resolvers. So with this change, like this has become really simple, and uh, uh, it also provides the APIs, as I mentioned, like update lambda script and get lambda script that you can see in the admin tab, like get lambda script. So I mean, yeah, this would be like uh, good. Like you can try it out and do let us know about your experience. Yeah. Uh, do post your questions, like whatever you have. Thanks, Aman. Over to Tiaga.
Thank you so much, Naman. Yeah, it was really nice, and lots of effort has been, done to actually integrate, because what we feel is that with GraphQL, we need to build the business logic, and there is no better way if, Dgraph in itself is providing all those features, right? And one of the most important thing is with Dgraph integrated, with Lambdas integrated with Dgraph, the resources are shared. So your Lambda can also scale to the within the same extent as your Dgraph Alpha. Okay, so if you have some complex use cases, you can equally scale, and you can equally extract the great performance out of Dgraph Alpha as well as the Lambdas. Yeah, so thank you so much, Naman. Over to you, Tiaga.
Hello, everyone. Thanks for joining the call today, and thanks Naman to show the Lambda magic in Dgraph with examples. Definitely, Lambda is a very exciting feature, and it allows you to simplify backend development a lot. So, to continue, I'm going to talk about a Dgraph Cloud. Last couple of months have been great. We have shipped a lot of features, and a lot of these asks were in the wish list for a while. We try to build the complete experience of Dgraph on Dgraph Cloud, so that we kind of help you to simplify the backend development. In fact, that's been the principle for Dgraph Cloud. We want to um, ridiculously simplify backend development, and make like Dgraph a single stop solution. So some of the key highlights which I'm going to talk about, it would be multi-tenancy. It's been there for a while, but then we did not really have a console support to manage namespaces, create tenants, and visualize these tenants on cloud. Finally, we have that support on Dgraph Cloud. Also, we have enabled ACL's console support on cloud, so you do not really need to launch Rattle to manage ACL. Now, everything can be done within the cloud interface. Taman has already talked about shards, so we can now, you can set the number of shards you want to launch your Dgraph cluster with. That helps you to scale your database horizontally, and that is helpful if you are expecting a certain spike in the traffic. You can quickly increase the number of shards without restarting the backend. One of the asks has been on Prometheus. We do have monitoring page on for dedicated instances, but we have also introduced Prometheus integration for those who want to have extensive monitoring and alerting and who are familiar with the Prometheus interface. One other thing which we have added is not a cloud feature, but we have moved to Zendesk so that we can give better better support and have a better user experience around support tickets, and so that our team could help you out if you get stuck somewhere. And the last thing is not really, again, a cloud feature, but like if you're a front-end developer, we as Dgraph is an open source company. We love to open source our tools. So one of the things which we have open sourced is Typhoon UI. That's the React UI framework which powers Dgraph Cloud. So if you're a front-end developer, please do check it out. And if you have some feedback, I'm more than happy to discuss that. So quickly, I want to jump on a demo. I know some of you would be seasonal users, so maybe you might already have seen these. Some of you would be new, so it could be overwhelming. So I'm just going to try to, keep a balance, try to, touch upon a few things and not really overwhelm with a lot of features which might not make sense for a beginner. So I'm just going to cover this multi-tenancy at large, and also try to give you a glimpse of other features as well. So it's very easy to launch a backend on Dgraph Cloud. All you just need to do is click on launch a new backend, and you have like three options. You have a free backend, which is just play around with Dgraph, and there's a shared instance, and then there's a dedicated instance. So multi-tenancy is a dedicated cluster feature. So I'm going to launch a dedicated backend for this demo. I'm going to just go with the defaults, not really going to make a lot of changes here. You can see that you can set the shard count here. So if you want to increase the number of shards for a cluster and scale horizontally, you can increase it from here. And also for Prometheus, you need to just switch on Prometheus in the additional settings. And for ACLs, and the same goes with ACLs and Audit Log. So since we are dealing with multi-tenancy, ACLs is a must. So I'm going to enable ACLs here itself. I'm also going to enable Audit Logs. You can just see how it looks like. And I'm going to go with the default configurations, give it a name here, and click on launch, right? So this typically takes a couple of minutes. So meanwhile, maybe I would like to put up a question to Manish or Aman. Like we have different types of clusters. How do we decide which one to pick up? Like, hey, I have a project. I'm a little confused. Do I take a dedicated instance? Do I take a shared instance? What's the difference? These are the questions probably a lot of people might have. So maybe Aman or Manish, do you want to talk about that?
Sorry, can you please repeat again?
Okay, so sorry, I think the audio was off. So can you talk about the differences between dedicated instance and a shared instance? When should I be using a shared instance? When should I be using a dedicated one? Yeah. And how do I go about configurations?
Yeah. So Dgraph actually has three different offerings. One is the free, the second is the shared, and the third is the dedicated backends. So free backends are just for our community and our users to actually test out and get the feel of what we are trying to offer and what we are trying to build. But it has many limitations like number of queries you can make and the data transfer. So that's just for to start with, but not something you can actually build upon it. The second offering which we provide is the shared backend, which is where you kind of share uh, your resources with other people, and the data is not shared obviously, but yeah, the resources are shared. And we do provide the shared backend across 5 different regions. The difference is that you have a bit of a less SLA guarantees there, so it's good for some dev environment and some small workloads, but we don't recommend that for production environments and where the load is expected to be high, because SLA guarantees are a bit less, and you might run into issues, and it won't be a good experience for you guys and your customers also. The third is the dedicated backends, which is our most one of the best offerings we have, where you have all the resources to yourself, and we provide some excellent SLAs there. And these are more recommended to run your staging and production kind of backends, where the stability is of more importance. We also have one question in our community, in our Q&A section, that when to actually go with shard increase, or when to actually go with increasing RAM or CPU. So the explanation is pretty simple. So we increase shard when there is so much data in one node group, that that node is actually spending too much time on actually processing those nodes. So generally what we have observed is, when you have more than 200 gigs of data in one group, it's actually the best time to actually shard, because what sharding provides you is the parallelism in terms of processing. So if you are querying, if you have one query, two different groups can process half of the queries at the same time, and you can have some great query performances there. Where RAM and CPU generally depend upon the use case, how you are using Dgraph on the runtime, where how heavy your queries are, how much processing it needs, right, to generate the results, how much data you are transferring in one query. So those are the factors which actually lets you to decide when to increase the RAM, CPU, or increase the shard counts. We do have this monitoring section, which I guess Tiaga will gonna explain, where you can actually see your metrics, how they are performing, like CPU, your memory, and stuff like that. And those will actually explain to you how, when is the good time to actually increase your memory, or increase your CPU count. Yeah, over to you, Tiaga.
Yeah, I know we kind of like debated it, but like, yeah, it's a good question. Like, when do I upgrade, or when do I upgrade my configuration, or do I increase the shards? I think the first thing you should probably look into is monitoring, like see the CPU usage, see if the machine is getting throttled, and then you can decide, okay, maybe, you need to bump up the configuration so that you can support the traffic which you are getting on your application. So monitoring is, again, a feature of dedicated cluster. So you can always look into the monitoring page and see the stats over here, right? So quickly, I'm going to go back to the backend which we created. So we just created a dedicated instance, and you can see on the dashboard, the configuration on the bottom right. So you can see that, it has a single shard, and ACL is enabled. So for creating for namespaces, so what are namespaces are like logical divides within your database. So you can have one single database and serve different applications or different tenants. It's very simple to use to create namespaces in Dgraph Cloud. All you just need to do is create a namespace, give it a name. In this case, I'm going to just put Pokédex. That will create a namespace for you, and you should be able to see it over here. And each namespace has its unique ID. And in this case, the namespace which we created is the namespace ID is 1. There's going to be always a default namespace that is tenant 0. So you cannot delete that namespace. That is the limitation. You need to have that one single namespace always. And you can create multiple namespaces, as many logical divides you want within your database, or like multiple applications you're building on the same backend. So, so how do I now switch between namespaces? For example, let me create one more namespace. Let's say Instagram app or something. So let's say I have two of these namespaces in my cloud. So if I go to schema page, actually there are three because we have a 10 and 0 as well. So if you go to the schema page, you're going to see an empty schema because we have not really updated anything. And you can switch between the schemas. On the top, you have this selection option where you can click on the namespace. So for example, I can click on Pokédex, add a type here. Let's give it a name and deploy this. So once we do this, and if we switch to the other namespace, we are going to see the schema to be empty. So I have already created a backend with multiple schemas so that we don't need to spend time on typing the schema. So let me switch to that. So here for Pokédex, I have this schema, and for Instagram, I have a different schema. So they're totally separate. They don't share any data. They are logically divided within the database. So you can have, so, and also you have a single endpoint for them, but then you can, with the access token, you can define which namespace you're referring to, right? So once it's generated, I've already added data into this namespaces. If you want to like create your own mutations, you can just go to the GraphQL, click on the namespace which you want, and it will show you the queries and mutations corresponding to that particular schema. You can use the Data Studio to see the data. So I'm going to just show you the data which is already added over here. So for Pokemon, Pokédex, I have some data added for the specific schema. And if I click on Instagram, I'm going to see the data inside that specific namespace. So the cloud UI kind of helps you to quickly wrap your head around namespaces, quickly visualize the data you have. You can also like query the data, kind of filter the data from here. Like you can sort the data, you can filter the data if you have the right directives in place. So in this case, like let's say I want to sort by followers, I can do ascending, I can do descending. So all those regular features work with namespaces as well. And one more thing is that you might be wondering like, okay, this is a console view for managing the database, but how do I consume namespaces from my client, right? That's the next thing you would look out for, right? So in this case, there's a good document around this. You can look into the docs for namespaces, and there's a quite an extensive article around like how do you create namespaces, and there's a section which talks about accessing namespaces via client. Namespaces are protected by default by ACL. That's why in the beginning I said you need ACL for namespaces to work. So a Dgraph Cloud internally takes care of the authentication and authorization, but from the client, you need to make sure that you authorize for that specific namespace. In that case, all you need to do is create a user group. So in this case, let's say for Instagram, I create a user group name, let's say users, and you have granular level permissions. So I can decide for which predicates you want to like allow the access for the user group. In this case, for simplicity, I'm going to just give all access and update this group. Once it's done, you can create a user. You just need to give a user over here. Let's say I call it admin, give some password here. So once this is done, you can select the group which the user belongs to. So I'm going to say belongs to users. So once this is updated, you have created a username and password, right? So we are going to just use that username password to authenticate with the Dgraph client. So if you're using any one of the Dgraph clients, all you need to do is pass the username and password. That will take care of creating an access token and do everything for you. So you don't really need to do the job of generating an access token. In case you want to not go via the client, and probably you want to build your own interface to access the namespace data. In that case, there's a mutation. So if you go to the GraphQL page, there are two endpoints here, client and admin. So most of the data which you'll consume would be through client, but some of the operations are in admin. So if you click on the admin, you have a different set of operations. And there's a specific mutation called login. So here you can just define the namespace ID, the password, and you can fetch the access token. So there is this mutation. I would just copy it from here. And I'm gonna put the password, user ID, and I'm assuming its namespace is 1. Okay, no, I think, sorry, this should be 2, right? So once you provide the namespace ID, username, and password, you get this access token. So you need to be passing this access token in the headers. If you want to see a good example, you can just go to the client. Let's say I want to add a user. And let's say I'm going to get the user object out of it, get me the email. So if you look at the code exporter, you should be able to see that we're passing a bunch of headers. So the access token which we generated earlier with the login mutation, we are going to pass it to the Dgraph access token. So that communicates the information which you require to decide to authorize that particular namespace. So that's how you would be accessing namespaces from the client side. Again, you can look into the document to understand how namespaces work and how you can leverage that to build multiple applications on top of a single database. So that is what all about around I had for multi-tenancy. The second thing is a quick thing I wanted to show is audit logs. So we had enabled audit logs. So there's a new backend. So if you see, it already shows all the operations which we carried up on our instance. So you can have a clear-cut view around the queries, the mutations, the status of the queries and mutations. So you know if there are some failures, any unauthorized access, all that information is available in audit logs and it's searchable. So if you want to see only GraphQL queries, you can just filter for GraphQL and you can export the data, right? So you have a complete visibility around access on audit logs. And if you already have launched a backend and you're wondering, how do I enable this? All these settings, you just need to go to the settings page, go to under advanced settings, you have a modify backend. Once you click on that, you get to edit all the settings which you had initially. So if you're already an existing user and wondering, how do I enable this? You go to settings and under modify backend, you have all these settings listed out. So I think with this, I've covered whatever I really wanted to present. Hope that was useful, and I hope you play around with these features and come back to us with your doubts and your feedback. We'll try to answer as much as possible. So over to you, Aman.
Thank you so much, Tiaga. It was really nice presentation. And yes, guys, so 2109 release candidate is out, and just go ahead and experiment with it, and do let us know if you have any feedback or any issues you face. You can raise your request over the discuss, and we'll be happy to help you guys in setting up and fixing all the bugs that if you face anything. And do share us a good feedback also if there is any, if you feel like we are doing some good job. So just give us a thumbs up and we'll be it will be, real pleasure for us. So, all right. So that's the everything we have for you guys today. And I hope you really enjoyed it. It was a real pleasure for all of us to present what we here at Dgraph are building for past couple of months. And I hope few of these features are really helpful for you guys, and you'll be pretty happy with what we are doing with Dgraph, and you'll keep using it. All right. Thank you so much. Do we have any other questions? I don't think, I think I have answered all. All right. Thank you so much, guys.